This is the second part of question 2a. So first part we have done. This is the second part. On the following grid, plot the appropriate quantities to create a graph that can be used to determine the acceleration A of the cart. The cart was coming down the incline. This was the cart, and this is the plus x. Along the incline, I have taken the plus x direction to be. So along this way, it was positive x direction. So clearly scale and label all the axes as appropriate. Draw a straight line that best represents the data. So we have x is equal to half a t square, right? Now this half a t square, I'm going to plot on the x-axis, and the position x I'm going to take on the y-axis. So this will be like a times t square upon 2. So this becomes the independent variable. This x becomes the dependent variable. A becomes the slope. A becomes the slope of the straight line graph that we are going to have. So these values I'll be plotting on the horizontal scale, and position I'll be plotting on the y-axis. I am going to get a straight line passing through the origin. Y is equal to m times x. This kind of a graph I'm going to have, where a is the slope. So let's locate the point. 0.07, this value is 0.6. So 0.6 and 0.7 are going to be like this here. 0.06, 0.07, around this point. Okay. 0.174 and 0.14. 0.14 and 0.174 is like this. Here. 0.296 and on the y 0.24. 0.24 on the y and 0.296, almost 3 here. Okay, so it's going to be here. Third is 0.46 on the horizontal and 0.37 here. 0.37 here and 0.46 on the horizontal. So somewhere here. And the last one is 0.72. 0.72 on the horizontal and 0.55 here. So this is going to be this point here. So I have marked all the points. Okay. If I connect the dots, I'm going to get a straight line passing through the origin like this. This is the straight line graph that we have. The x-axis, we have t square by 2. Here we have the position in the positive x direction. X direction, positive x direction I have taken down the incline. So this answers this part here, part 2. Now the third part, using the line you drew in part A, calculate the experimental value of the acceleration A of the block as it rolls down the incline. So that means we have to basically find the slope of this line. So finding the slope of line, just I'll take any 2 points. Okay, let's say take this and this, and I find the slope. The slope of that one is going to give me the acceleration. The slope of the line is going to be given by this minus this, 0.296 minus 0.174 upon this minus this, 0.24 minus 0.14. This simplifies to 1.22. So the acceleration of the block down the incline, by finding the slope of this graph that I got from the experimental value, the acceleration of the block I'm getting, A is equal to 1.22 meters per second square. This is the value of the acceleration that I'm getting using the graph, right? This answers the second part of question number A here, right? Thank you.